The purpose of today's lesson is to take what we previously learned regarding transformations and use specific transformations to justify why two figures are congruent. So let's just review some prior concepts, which we've gone over a number of times. What is a translation? A translation is a transformation in which a figure moves the same distance in the same direction. Okay? And if you recall, the word we used for translation was slide. A reflection is a transformation in which a figure is reflected or flipped over a line. And then lastly, a rotation is a transformation in which a figure is turned or rotated about a fixed point. Now, you'll see that I've purposely left off dilation because these three transformations are the only three that keep the figure the same size. It's just been moved somewhere. A dilation does not do that. So, why did we pick out these three? It is because they give us what are called congruent figures. And what does that specifically mean? We say that two figures are congruent, and the symbol for congruent is the equal sign with the tilde on top, because we're not talking about numerical congruency, we're talking about geometric or shape congruency. So two figures are congruent if they have same size and the same shape. If two figures are congruent, then corresponding angles and corresponding sides are congruent. Meaning the angles that match up with each other and the sides that match up with the other are congruent. And what we're saying today is that if you can tell me the specific transformation that it underwent, and specifically translation, rotation, or reflection, if you can tell me which one of those three, or two or three of those three, a figure underwent, then you're telling me the two figures are congruent. All right. So let's take a look. I want it to determine if ABC and A prime, B prime, C prime are congruent. And to be able to do that, you just can't say, oh yeah, they look like they're the same size and shape. That's not good enough. You have to prove it to me by giving me one of the transformations. Well, hopefully if you go through the series, I did not flip A, B, and C, so a reflection is out. I did not turn A, B, and C, so a rotation is out. All I did is I moved it down and across. So they are congruent because it is a translation under the rule X, Y went as follows. I went down 9, which is a minus 9, and I went right 4, which is a plus 4. I can do that with any of the three points are all of the 3 points. So what was the rule? I added 4 to the x, and I subtracted 9 from the y. Okay? Number 2, are they congruent? Yes. We rotated 180 degrees about the origin. Okay? You don't need to tell me clockwise or counterclockwise because you still get the same place no matter which direction you took. And what you can see is that I went from -2, 1 to 2, -1, meaning all of the signs were reversed. Okay? Next example. One heart going to the other. Now, since I don't tell you which one is the original and which one is the image, all you would tell me is, yes, it's a 90-degree rotation about the origin. Now, since I have it color-coded here, if I told you the red was the original and the blue was the image, then that would be 90 degrees clockwise because I would go that way. Or if I went from blue to red, that would be counterclockwise. All right? Number 4. Now, you could probably say, well, wait a second. The distance between from one point to the other. So this distance is 3. This distance is 1. So that's the same thing down here. That's good, but that's not sufficient. All right? They are congruent. How do we explain it? Well, let's take a look at what happened. Hopefully you can see that there's been some sort of flipping because it goes large size to the small size. Now I'm going, if I go left to right, small size to the large. So how would I describe what happened here? I reflected it in the y-axis so that I ended up here. So there was a reflection in the y-axis followed by a translation where I slid it only down. So x doesn't change and y went down by 6. Okay? Now, could I have done this a different way? Well, let's see. What if I reflected it over the x-axis? Sorry for that little delay there. So that it looks something like that. And let's just see, we'll call that A, B, C, and D. So that it becomes D, B, C, B, and A. I'm just using the points to match things up. So I reflected it there. And what if I reflected it again one more time? That looks like it works also. So one of the things that you can see here is I could have done a double reflection, one in the X and one over the Y. So you'll see sometimes there's more than one answer to these problems. All right? Let's look at the final 2 questions. Hopefully you'll see that, yes, and it's a 90-degree rotation about the origin. Okay? And then, now you have it drawn on your paper, but I'm going to draw it here. So C is 2, 1, B is 1, 3, and A is 5, 5. So here's A, B, C, and then my primes, C prime, B prime, and A prime. Now, one of the things, and you've got to be able to recognize this, one of the things you should hopefully recognize is that things have flipped around somehow. The A is on the top over here. This is what I'm talking about. A is on the top, C is on the bottom. Now C is on the top, A is on the bottom. That's a clue that there's been a reflection. So let's say I reflected this in the x-axis. Where would I end up? Well, I'd end up, sorry about that. New C would be 2, -1. New B would be 1, -3. And new A would be 5, -5. So it first looks like they are congruent, that I reflected in the x-axis. And then it looks like all I simply did was shift this whole thing to the left. And that's correct. A shift like that is called a there's my S-lation. And how did I do it? X didn't move. Y didn't move. X shifted 5 units to the left. Okay, so just to recap the lesson, what we did today is to demonstrate that two figures are congruent, and we need to use a translation, a rotation, or reflection to justify our conclusion.